from Department of Forestry from Chongqing University, and I'm going to present reverse casing Taiwan red cypress distribution from topographic sheltering effects on Taiwan fir in Hehuan Mountains. And today I'm going to present from introduction to conclusion. Ecological niche modeling, we call ENM, becomes an important tool for ecological conservation and environmental monitoring. And ENM is based on statistical methods to qualify the relationship between the species distribution and its surroundings and to map potential distribution of the species. And in recent years, ENMs coupled with 3As, GIS, RAs, and GPAs can quickly provide useful information for monitoring and management. And we have read some previous study. We found out topographic sheltering formed by mountains protect Taiwan fir from a high wind so that Taiwan fir can grow in valley or depression rather than near the ridge or peaks in Hehuan Mountains, just like the picture shows. You can see in a red circle, the Taiwan fir grows well in the valley, but there are no any Taiwan fir on the ridge. We can see another picture that has the same phenomena. And in other case of the topographic sheltering effect in Nika, we can see the blue circle, the plants grow well in the valley, and we can see in the green lines, there's no any plants on the ridges. Therefore, we have three objectives. First one is we are going to confirm current use variable except elevation to be used as for explaining the absence of TRC in most of Huizun area. And the second one is we are going to evaluate the effects of different training sample size on the performance of each method. And the third one, we are going to determine which model is the most useful for the ENM of the plant species. And I'm going to introduce our materials and methods. First of all, our study area contains Huizun Forest Station. This is one of the 4 forest stations of Chongqing University, and we adopt a rectangular area contains 17,136 hectares. And you can see a blue area. This is our sampling area. It contains about 88 hectares. And our study species called Taiwan red cypress is one of the valuable timber in Taiwan and mainly grows in central mountains. And most fall within the elevation about 1,500 to 2,150 meters, and normally grows in far forest belts. And this is what Taiwan TRC looks. And what is the far forest belt? It belongs to mesothermal deciduous forest, and the most important feature is relative humidity. It's about 81 to 94%. So it always looks like this picture. Next, I'm going to introduce our study process. First is our sampling point. We got our sample from field survey and this forest type map. We can see the red circle with zooming. We can see the nearby the Shoucheng mountain. There's pure forest of cypress, and we compare this phenomenon to the nearly forest resource and land use survey in Taiwan. We found that they are similar, so we directly digitize this area for our sampling. Next, I'm going to introduce our variables. We use EM, also photo mass and spot file image, to produce elevation, slope, aspect, zero position, and vegetation index, 5 variables. And here's another variable we will use in the future, but this variable we haven't completed yet. And this is a concept of windbreak forest, and we use point in polygon operation in GIS. And we assign the ridge cell itself as a weight value of 0. And if the ridge cell is found somewhere in a compass direction of non-ridge cell, we assign a weight of value of 1. And if the prevailing wind direction of the study area, we assign a value of 2. And if the edge of the data later is reached without encountering a ridge cell, we assign a value of 0. You can see this picture. We assign direction 1, 2, 4, 6, and 7 for the value of 1. And we assign a value 0 for 3, 5, and 8. And if our prevailing wind is from the northeast, we assign a value of 2 for the direction 2. And we consider the distance of our target cell, and we convert into proportion between 0 to 1. We can see the following picture. The target cell A, if it's the left one, it has a bigger number value of than the right one. That means it has a better topographic sheltering index. And we use this function to calculate our index. And I'm going to introduce our sample selection. We randomly select 5 sample size of a training sample, and we select background points 5 times more than the training points. And finally, we use the independent sample to test our model. And this is the 5 sample size of our research. After we got our variables and our sample points, we overlay and then clip the information we need for our models. After that, we are going to construct our models. In this study, we developed 3 models: GLM, BPNN, and MakeSense. Finally, we are going to validate our model. We adopt kappa index using independent samples to validate it. And kappa index is produced by error matrix and consider commission and omission errors. And we use the following function to calculate it. And this is our results and discussion. First, we are going to consider the 5 relative importance of our 5 variables. We can see that in the MakeSense and GLM, the elevation and the slope are the more important variable of this research. But the BPNN did not provide relative importance, so we just consider the MakeSense and GLM. So we use the elevation and slope for following tests. And now we are going to evaluate what if in different sample size, what the performance of the 3 models. We can see that if when the sample size reach 351, they cannot significantly improve their accuracy. So that in following prediction, we are going to use the 351 and the elevation and slope for our potential distribution map. And this is the GLM's prediction map. We can see that in the whole area, TRC just appeared near the Southern Mountain. And we zoom in this area to see it. We can see that GLN has an expanded prediction so that it becomes more commission error. And we can see that BPN is similar to the GLN. It was expanded, so we zoom in this area and can also see that it has more commission error. And then the maxim, we can see has the same phenomenon that the TRC just appear near Southern area. But we can zoom in this area to see it has more limited, so that it has more omission error in maxim. Therefore, we found out that in our Huisun Forest Station in the northeast has 3 main ridges in Taiwan, and we thought that they block the humidity, so that the lack of, we think this is a key reason, the lack of humidity in the Huisun area. In our conclusion, the predicted accuracy of 3 models generally was dipped with the increase of sample size, except BPNN. And GLN and maxim, the accuracy could not be significantly improved as the sample size reached a certain number. We found that there's a 351. And we can find that the model performance, the GLN is better than the BPN and better than the maxim. And we found that maxim was significantly worse than the others. And also, we found that the variable we use, except elevation, cannot show almost useless for explaining the absence of TRC in most of Huisun area. So that we reverse thinking the micro-theorem sheltering effect for the Taiwan fir. We propose a hypothesis that topographic sheltering around Huisun on a large spatial scale would have an effect for the growth of TRCs. And just like I said before, the main region of Taiwan, we think that they block the humidity from the season wind of northeast season wind, so that in Huisun area there are a lack of humidity, and we are going to confirm this hypothesis in a subsequent study. And finally, we found that in our variable, the variable are used for this prediction, so that we attempt to incorporate climate factor or proxy indicator like topographic sheltering index to improve our prediction or improve our accuracy of our models. Thank you for listening.
Any questions or comments? I have questions. Yesterday I asked one presenter a similar question. My question is about model. So maximum entropy, max ENT requires presence samples only. But generalized linear model or logistic regression requires both presence and absence samples. So when absence sample is not available, we usually define a pseudo absence samples. But my question is, did you use the same background or pseudo absence sample for all models?
Yes, we use the same background sample.
But in my opinion, maximum right and maximum entropy model requires only presence data, but it intrinsically uses background samples. But the background samples for max EFT is conceptually different from pseudo-absence. Background samples may include absence and presence, but pseudo-absence means non-occurrence. So it's totally different. But I think you use the same background samples for modeling procedure. So please check it out. This is my question is between question and comment.
Thank you.
Any other questions or comments?
Is the ecological Nietzsche model is freely available in everybody? Is that free program?